So, in the last lecture we have learned about different operations on fuzzy set. So, different operation on fuzzy set that we have learned is basically given a 2 fuzzy set or a fuzzy set, how another fuzzy set can be obtained. Now, we are going to learn another concept in fuzzy logic, it is called the fuzzy relation. So, by means of fuzzy relation we say that if one element belongs to a fuzzy set, then how this element is related to another fuzzy set. So, this basically the relation between the two elements which belongs to the two different fuzzy set. Now, so fuzzy relations in many way related to the Crip's relation. Crip's relation means the relation those are there on the Crip's set. So, we will first learn about the Crip's relation and then whatever the operations those are possible on Crip's relation is basically applicable to the fuzzy relations also, but there are certain difference. So, it will be better if we learn first operations on Crip's relation and then the operation that can be applied to the fuzzy relation. Some examples also will be considered in order to understand the Crip's relation, and then we will be in a position to know fuzzy relation. Some examples operations those are possible on fuzzy relation, and finally, we clear our idea with some examples. So, these are the topics that we are going to cover in this lecture. So, let us first discuss about the Crip's relation. Now, Crip's relation basically is an collection of order pair. So, if A and B are the two sets, then its order pair is denoted by the Cartesian product A cross B, and it basically gives the collection of order pair A B such that A belongs to the set A and B belongs to the set B. Now, so this order pair relation is important to understand the Crip's relation. Now, a particular mapping is basically belongs to a particular relation, and we know so far the Crip's relation is concerned, these are the different property holds good. The first property is that A cross B is not equals to B cross A, that means they are not commutative, and here is basically the number of elements which is belong to the product is same as the number of elements belong to the constituent set A and the product of the number of elements belong to the set B. So, this also equation hold goods, and as I told you A cross B essentially provides a mapping from a set from an element belongs to set A to another element B belongs to set B. So, it is basically a mapping, and this mapping is expressed by means of an order pair, and this particular mapping is called a relation. Now, we can understand this relation better if we consider an example. So, example, suppose two Crip's set A and B, and A is represented by this form and B is 3, 5, 7. So, these are the two sets A and B, and we can obtain their Cartesian product. Cartesian product we can obtain for these two phases is all possible order pairs. So, it is shown here, this is the Cartesian product of the two fuzzy sets A and B. So, here for example 1, 2, 3, then 1, 5, 1, 7, then 2, 3, 2, 5, 2, 7, 3, 5, 3, 3, 3, 5, 3, 7 and so on. So, these are the different what is called the elements which belongs to the Cartesian product of the two fuzzy sets A and B, and then the relation. I told you the relation is basically a particular mapping. Now, here we express the relation, and this is suppose the relation that we have discussed here. So, relation between the two order elements in a order pair should satisfy this equation. If it satisfy, then it gives a particular set, or it is basically relation which is shown here. Here for example, if this is a relation hold good for every element, then the relation that can be obtained is basically this one. So, a relation is basically a collection of order pairs which satisfy a particular mapping or a particular definition. Now, so this is the Crip's relation, and such a relation can be expressed in a more compact way, and this compact way it is called the matrix representation of a relation. Now, the matrix representation of the relation which we have learned earlier. So, R is 2, 3 and 4, 5 is denoted by this matrix. You can see 1 and 3 which is not belongs to this set. So, it is 0, and the elements 2 and 3 belongs to this set. So, it is 1. So, here 0 and 1 are the entries in the relation matrix. 0 indicates that order pair is not belongs to this relation, and 1 indicates that order pair belongs to the relation. So, this way a relation can be represented by means of a relation matrix. Now, so operation on Crip's relation. So, these are the relations, if it is available to us, we can apply different operations on it. Say suppose R and S are the two operations defined over x and y, where x is the some elements belongs to the universe of discourse x, and y is the element belong to the universe of discourse y. So, R x y can be obtained as a relation matrix. Similarly, S x y can be obtained by means of another relation matrix. So, if the two relation matrix are available to us, then we can apply many operations on them. So, the operation on them that can be applied can be applicable is union, intersection, complement, like this. Now, you can find the difference between the union of two fuzzy sets and union of two fuzzy relations. So, union operation of two fuzzy set is expressed by this form. So, R is the relation and B is the S is the another relation, right, and this relation obtained over the two Crip sets, say A and B. Then the union of the two relations can be defined as a max of the two entries in x and y in both relation. So, one example can be given here. So, this is the union operation. Likewise, the intersection operation is basically minimum values of the entries, and the complement is 1 minus the entries in each elements. Now, one example that can be considered here. Suppose this is the one relation that can be obtained over A and B, and this is another relation obtained over the sets A and B. So, it is basically A cross B with some relation, it is also A cross B with different relation, and then we want to obtain union of the two. So, union of the two we can write R union S. So, it is basically one matrix. Now, union operation, as I told you, it is the max. So, 0 and 1. So, you have to take the 1, 1 0, it is 1, then 0 0 for the first rows. Similarly, 0 1 1 0 0 0 1 1 and 0 0 0 1. So, this is the another relation matrix that can be obtained using the operation relation operation of the two relations R and S. So, this way we can obtain the relation. Now, using the same concept, you can find easily the union of 2, intersection of 2 and then complement. Now, so far the complement operation is concerned, R complement, this is equals to, it is basically complement value. So, if the 0, then it will be 1 and it is a 1 then 0. So, we can complement of this is this and then 1 1 0 1 1 1 1 0 and 1 1 1 1. So, this is the complement of the relation R. Now, there is another important relation, it is called the composition, and composition relation is widely applicable in the context of fuzzy relation. So, composition operation, it is denoted by this symbol R composition S. That means, from two relation we can find another relation, but so this R relation suppose over two set A and B, and S relation is over another say A and C. So, here C is the one common set, then we can obtain R combination S basically relation from A to B via C. So, this is the concept that is called the composition. Now, composition operation can be defined mathematically using max min calculation. The max min, it is called the max min composition, this is why, and is denoted by this expression. Max min composition is basically this one. Now, it is little bit difficult to understand at the moment. So, I can give an example so that we can understand it. It basically follows the similar concept of product of two matrix actually. So, it basically take the first minimum of corresponding entries and then take for a particular entries the maximum value. So, let us have some examples so that we can understand the max min composition or simply a composition operation to relation. Now, this is the one example we have to consider carefully. So, suppose x is the one universe of discourse, y is another, and the relation R x y defined over x and y, and S is also another relation defined over the same discourse x and y. The relation that is there for a R, it is basically this is the relation and this is the relation that is there in S. Now, based on these things we can easily obtain the Cartesian product, and then applying this relation we can obtain this matrix and this matrix. Okay. So, these are the two relations obtained from the two fuzzy sets, two Crip set x and y. Now, having this relation we can find the composition of the two. Now, composition basically we take first row wise and then column wise just like a product to obtain the first element here, sorry. So, this is the row and this is the one to obtain the first element here. So, it basically take like, so 0 and 0 take the minimum. So, minimum is 0. So, 0 is the minimum, then 1 and 1 as 1 and 0, then it is the minimum is 0, then 0 and 0. So, minimum is 0, and then take the max of this. So, this is 0. So, this is the 0. For the next element we can obtain, so this and then this one. So, 0 and 1. So, for the next, okay, for the next this one and then this one. So, we can get this element. So, this and this we can go. So, that means 0 and 1 take the minimum, it is 0, and then 1 and 0 take the minimum, it is 0, and then 0 and 0 take the minimum, this one, and then maximum. So, it is 0 1. Now, let us see how this element can be obtained. So, again we have to take this one and then this one. So, first 0 and 1 0, then 1 and 1 1, and 0 and 0 it is 0, and taking the maximum this one. So, it get this one. So, these elements again we can be obtained if we take this one, then this last element can be obtained. So, this way we can obtain the relation called the max min composition of the two relations R and S. Okay. So, it needs little bit practice to understand it. So, it will basically take the mean corresponding to this traversing and then taking the max of all this will give a particular element. So, this is the idea, and now let us see how these operations, those are applicable to the Crips, is also applicable to the fuzzy, but in a different one. So, difference between the fuzzy relation and Cripps relation lies in the terms of entries in the relation matrix. In case of Cripps relation, the entries in the matrix is either 0 or 1, whereas in case of fuzzy relation, the entries in the matrix is any value in between 0 and 1, both inclusive. Now, let us start with an example about the fuzzy relation. Suppose two fuzzy sets which is described over the 3 elements which is here, one fuzzy set is x and another fuzzy set is y. The different elements in the fuzzy sets are here. In x it is typhoid, viral, cold. In fuzzy set y, the elements are there running nose, high temperature and shivering. Now, you can understand what is the meaning of these two fuzzy sets and the relation then. So, basically here if the disease is typhoid, then what are the different symptoms are there. So, if the disease is typhoid, the symptom that running nose, yes, but with the strength 0.1, high temperature 0.9 and shivering 0.8. So, every disease and the different symptoms with the different membership values is represented and by means of a relation matrix. So, if it is a viral, then what about the shivering? So, shivering is 0.7. If it is a viral, then running nose, but running nose with little bit less uncertainty than the shivering, that is 0.2 and 0.7. So, the relation matrix basically shows the different elements which are belongs to the different sets, how they are related to each other. So, this basically the physical significance of the fuzzy relations. And now, one thing it is clear that the elements in the fuzzy relations, that means the entries in the relation matrix is basically any value in between 0 and 1, both inclusive. So, this is the only difference between the fuzzy relation and the Cripps relation. Otherwise, every operation those we have defined in case of Cripps also equally applicable to the fuzzy sets. Now, let us see what are the different operations that are possible for the fuzzy relations. So, here so the fuzzy relation again defined as in the Cripps relation like the mean operation. So, it is the mean actually. So, this is the mean operation. Let us see one example. So, here say A and B are the two fuzzy sets, A and B are the two fuzzy sets. Now, I can find a relation. The relation can be obtained as we have discussed here. Now, relation operation that can be defined over two fuzzy sets, it is basically represented by this expression that mu r x y, where is the membership value belong to relation and it is denoted by A cross B, as I told you Cartesian product of x y, and it basically takes the minimum of two corresponding values in both the set A and B for x and y respectively. So, it is basically taking the minimum. Let us have an example, so we can clear our idea. This is an example can be followed to explain the relation operation for the fuzzy set in terms of Cartesian product A. Now, here A is the set which is defined like this, B is the another set which is defined like this. Okay. And then the relation R is basically Cartesian product as I told you. So, is basically for A 1 and B 1, A 1 and B 2. So, A 1 B 1, A 1 B 2. Now, for A 1 B 1 we have to take the minimum. So, 0.2 and 0.5 take the minimum. So, it is the minimum entries. Similarly, A 1 and B 2 0.2 and 0.6 take the minimum. So, 0.2. Likewise, A 2 B 1, so minimum is 0.5, A 2 B 2 the minimum is 0.6, A 2 okay. So, this is A 2. Now, A 3 and B 1, so 0.4 and A 3 B 2 0.4. So, this way we can obtain the relation matrix taking the mean operation that is there. So, this way we can obtain the relation if the two fuzzy sets are given to us. Now, let us define different operations on fuzzy relation, like the different operation in Cripps relation. So, like union, intersection and then complement, these are the operation. So, union operation on two fuzzy sets can be defined using this expression. It is basically taking the maximum value of the two entries there. So, it will give the new matrix taking the maximum of the corresponding entries. Intersection basically taking the minimum of the two entries, and complement, it is a unary for one operation. So, we take the, if it is mu r b, then the value or entries in the relation matrix will be the complement, that means 1 minus mu r b. Now, some example can be followed to understand this concept. Another composition, I will discuss the composition operation in details in regards to the fuzzy sets. It is basically same as max min composition, taking the similar concept. Now, better we, if we have one example. So, X is a Cripps set, Y is another and Z is another. So, we can consider they are the universe of discourse for the fuzzy sets maybe, and so R, this is the one relation defined over two sets which is discussed over the universe of discourse X and Y. So, this is the relation over the two fuzzy sets, and S is the another relation which is defined over Y and Z. So, these entries are given to you. Okay. Now, if it is given to you, then we can calculate R union S easily. Now, again here we can say R union S, here basically elements those are not same, that is why we cannot apply R union S, but the two, I mean union operation is applicable if the two relations are defined over the same elements. So, if this relation is defined over this one and this one, then another relation should be defined this one, then only we can. For example, suppose I defined another relation P and x 1, x 2 and x 3 and y 1 and y 2 and say 0.1, 0.2, 0.2 and 0.5, 0.3 and 0.4. So, this is the relation. Now, if we want to find the union of the two relation, so R P, then relation basically taking the maximum of the corresponding entry. So, 0.1 and 0.5. So, in the first entry 0.5 and then 0.2 and 0.1. So, we should take 0.2, 0.2 and 0.2. So, 0.2 and 0.5 and 0.9, 0.9, then 0.3 and 0.8, 0.8, then 0.4 and 0.6, it is 0.6. So, this is basically the relation obtained over the union operation of the two relation R and P, and you can note that R P, this is equals to same as P R, that means they holds the commutative property. Now, likewise the intersection we have to take in, so it is basically take the minimum of this one, union where is the maximum and intersection is the minimum, and then complement also can be obtained. For example, so complement operation this R bar that can be obtained like, so 0.5, then 0.9, then 0.8, then 0.1, 0.2 and 0.4. I hope you have understood how it is obtained. It is basically taking the complement, so 1 minus 0.5, 1 minus 0.1 and this way. So, this way the complement operation over a relation R can be obtained. Now, this is another example that I am going to discuss, is a composition. So, R and S are the two relation and we want to find another relation T which is a composition of R and S. So, using the max min composition, it is the composition that we have discussed about the Cartesian product finding. So, take the minimum first and then for the minimum of all take the maximum. Again we can follow, it is this one and this traverse. So, it will give this one, that means 0.5 and 0.6 we have to take the minimum. So, it is 0.5 and 0.1 and 0.5 we have to take the minimum 0.1 and taking the maximum of this. So, 0.5. So, this is 0.5 and likewise if we traverse this one and this one, this element can be obtained, this one and this one, then this can be obtained, this then this element can be obtained and so on. So, this is the max min composition operation that can be applied on two relation R and B. Okay. So, this is the relation operation and I can give another last example in this direction. Here this example is very interesting to note. So, P is the set with different element P 1, P 2, P 3, P 4, D is the another set with different elements say D 1, D 2, D 3, D 4. Now, in the context of our real application, so P basically consider a set of varieties of paddy plant, that means P 1 is a one type of paddy plant, P 2 is another and so on. Now, D, the set D represent the different diseases, where D 1 is a type of disease, D 2 is another and so on, and say S is the another set which basically set of symptoms. Those symptoms are S 1, S 2, S 3, S 4. Now, how a particular plant is related to the disease, that can be given by means of a relation. So, this is basically a fuzzy relation showing that how a particular plant is related to the different disease that may have. For example, P 2 is a plant and is susceptible to disease D 1 with the 0.1 certainty, D 2 is 0.2, D 3 0.9 and D 4. So, we can say that P 2 is very much susceptible to the disease D 3 or D 4 and less susceptible to the disease D 1, D 2. It is the concept. So, this is the meaning of the fuzzy relation. Now, having this fuzzy relation R, we can obtain another relation by means of composition operation. Say S also another relation, it basically showing the relation about disease and the symptoms. So, here different disease are there and different symptoms, and this is the matrix showing how particular disease and related to the different symptoms for that. Now, having this one, then we can have the composition operation. So, T is a set resultant which is basically R composition S. So, R composition S can be obtained, previously we have discussed about R and this is the S, and taking the max min composition, then you can try and you can check that this is the relation that can be obtained. So, this relation has the meaning, this meaning is that if the R relation shows that which paddy plant is susceptible to which disease, and if S denotes the particular disease and what are the symptoms, then R S basically shows a particular plant, then what are the symptoms that it basically corresponding to some disease. So, this is the relation showing a plant and then symptoms that they may be affected. So, this is the one example, and I hope you have understood the concept of relation. And this is another example, that is the I can give it very quickly so that you can understand. If R is another relation showing the relation from these sets to these sets, this is the R relation is this sets to this set, and another relation S showing the relation from this element to this element. If given this one, then I can find a relation from any to any one. So, via this one. So, alpha beta gamma is a basically in between the two, and then we can find a relation 2 to A or relation 2 to B. So, that can be obtained by means of Cartesian product and then relation composition operation rather, not Cartesian product. So, it can be like this one. For example, 2 here 2 is the element which is belongs to a set, and these are the different and A. So, we can find the relation from 2 to A by means of max min composition. How the max min composition is can be calculated, which is shown here. So, it basically here for example, 2 and A, there is a relation via other elements alpha beta gamma. So, the relation that 2 is related to A with strength 0.7. Similarly, we can calculate likewise the 2 and A, relation between 2 and A, we can calculate relation between 1 and B or 1 and A with some what is called the strength. So, this basically shows the relation and it is the meaning it is there. Now, so I think time is over. So, we can stop it here, that this portion can be discussed in the next lectures. Okay, thank you.